Sri Rajaya Vivekananda Sure. Hello everyone, my name is Sourav. I'm a senior research scholar working under the guidance of Dr. Uttam Kumar Godai at Ramakrishna Mission Vidya Mandira. It's a privilege for me to be able to present my thesis in the INYAS platform to the scientific fraternity. Well, if we look into the modern world, the present scenario is not very pleasant because the greenhouse gases emissions have already polluted the atmosphere. The industrial effluents have been dumped into the water bodies, which have deteriorated environment as a whole. So in order to see a future of a better world and a greener world, we must act fast. The world leaders have agreed upon to work on the global goal of net zero carbon by 2030 in the Paris Convention. So what is the solution? Well, two chemicals, ammonia and urea, can be a game changer because in order to synthesize them in industrial scale, it demands a high temperature of about 500 degrees centigrade and a pressure of 300 atmosphere. So if we can produce them in industrial scale but in a greener route using renewable sources of energy, then we can majorly impact the research. This forms our thesis objective. And also, this is very important from Indian context because these two chemicals are the pillars of the fertilizer industry, and our country is a agriculture based economy. So our research has two aspects. First, nitrogen reduction to ammonia. Thereafter, ammonia, which has been synthesized, has been coupled with CO2 to form urea. We all know from school days that nitrogen is an inert molecule having a high bond energy of 941 kilojoule per mole, and hence, therefore, it is very difficult to dissociate. Taking inspiration from nature, we saw the structure of chlorophyll and designed our molecule on that note. And we designed cobalt halocyanide, which is having a unique metal center, metal coordinated with the pyridinic nitrogen, forming MN4 site, which acts as an active center for nitrogen reduction, as also a suppressing site for hydrogen evolution reaction. Thereafter, we optimize the electrochemical cell, where the two compartments, anodic compartment and cathodic compartment, is separated by a proton exchange membrane. In the cathode, the nitrogen reduction takes place, and for urea synthesis, CO2 is purged, and then the CO2 and the ammonia formed couples by the CN coupling reaction to produce urea. The catalyst that has been synthesized is of nanotubular morphology, which is placed in the working electrode. It showed its proficiency in stability aspect by remaining stable for about 20 hours. It showed its activity, and it has been very selective because it successfully suppressed the competitive hydrogen evolution reaction and also minimized the byproduct hydrogen formation, and it has been recyclable for about 10 cycles. We are Apart from publishing in high impact journals, we have also filed for 2 US patents and 3 Indian patents, and our patent has been already adapted by a multinational company, and we have achieved the technology readiness level of 5, which makes our product and Make in India initiative. Thank you for your time.